Right, in this tutorial, we will look at mask fills using the threshold controls. In this video, we will see the soften pixelation option, which I forgot to include earlier. Let's import an image to work with. When zooming in, the pixelation is quite evident, even in the final result. If we apply the soften pixelation function, well, we can now see the result, which honestly improves quite a bit. Smooth pixelation interpolates pixels using 4 types of interpolation. To select them, go to Options, Smooth Pixelation, and there you will see the 4 types available. They are ordered from lowest to highest. Bcubic would be the lowest, yet it already gives good results. Bilinear, a bit higher quality. High quality Bcubic would be, well, in my opinion the best, because high quality bilinear, well, I think it makes it blurry, but everyone can choose the one they want. It is not always a good idea to use interpolation. For example, if we had an image already digitized in black and white dots and not in grayscale, well, this interpolation generates gradients from the white to the black dots, and that alters the result. If we remove the interpolation here, for example, well, the result is more accurate to the original image. Well, we will look at mask filling using threshold controls. To do this, we will see a practical example. We will digitize an image that turns out to be somewhat difficult. Alright, here we can see this image. Digitizing this image presents several problems. The first is removing the background, something we can easily do using a mask to exclude it, but there is more. For example, the shine in the hair. Here on the right, we see brightness, while on the left, we do not. So in that case, what we can do is use different thresholds for those two areas of the image. More problems would arise if we define, for example, the eyes. We see that the mouth does not appear, and if we make the mouth appear, the eyes and the rest of the image become overloaded. So, in tasa itorida paranomias, Yamano would be the same here. Define two zones, one for the eyes and one for the mouth, and apply a different threshold to each. Right. The first thing, as I said in the other video, is to position the image, set the image position and size, because when we start using masks, the position and size controls get locked, right? We would have the image positioned now. We remove the threshold and start generating the mask. Now, we are going to create a specific mask for the hair. Well, we have a problem here, which is that the hair color is practically the same as the background. Sometimes the mask overflows because it cannot find boundaries, since the background and the hair are similar colors. Press Ctrl+Z and delete the previous state. In the mask, even if we set the automatic sensitivity to the maximum, the mask overflows. It can happen, for example, that from the inside to the outside, it does not detect the edge well, but the opposite does. So, in that case, what we are going to do is detect the edge from the outside, the part located on the left. And, well, the truth is we are going to start to select everything. And now what we are going to do is subtract the right part of the background, which is the same. With automatic subtraction, we increase the sensitivity to the maximum. And that way, we exclude the background behind the head. Very well. I think we could manage to outline all of this in a completely manual way. And well, we would now have the inside of the image. Right, here we can apply a threshold, but well, we still have the problem that the mouth doesn't appear if we define the eyes, and if we make the mouth appear, the rest of the image gets overloaded. Let's exclude the interior of the image we are seeing and proceed to create an independent mask for each part, for every part of the image. We will call this mask hair. We will exclude the inside of the image manually, or better, Ctrl+Z and we try automatic. Well, in this case, we will have to outline it manually. The more time we dedicate to the image, the better the result we will get. And well, now we have the hair, and we apply an individual threshold to the hair. Here we will have the hair, and then we see the problem I mentioned before. The highlights on the right do not appear. It is as if some hair is missing. In that case, we will create two masks for the hair. One will be hair 1 and the other for the highlights of that hair. We label it hair 2, we set the sensitivity to the maximum, and we add. It is not necessary to add all the hair, just the light tones of the hair. The parts that have shine in the hair we are going to try to subtract this, and here we are going to detect the light tones. The rest of the hair is now appearing, as you can see. Now we are going to create another mask for the eye area. We will do it manually. And we apply a threshold to it. And finally, well, we have the mouth left. We do the same, but manually. And we apply a threshold. What we have done here is set different thresholds for all the different parts of the image. Well, apart from this, one last one, which would be the chin. We do it manually, and here we simply detect the edge. Here we see two lines, one at the beginning of the shadow and one at the end, so we try to make the mask only capture one. Dos asintos inta sua asinka finka afas. Now it has detected no single shadow, perfect, and now we can manipulate each of the different areas of the image completely independently. This result is for a positive LCD. If we wanted to implement it on a negative LCD screen, like blue and white, well, what we must do here is invert all the pixels, that is, turn on the background that is off and turn off the ones that are on. So, in that case, we go to the main image background, set a solid fill for everything, and proceed to turn on the pixels. We don't see the hair here because the threshold has its own fill, which is generating pixels in the on state. We would have to tell it to generate pixels in off first. So the hair now appears, and the same goes for the rest of the masks. And this will be the way to work if we are going to use negative LCD. And finally, the chin. Well, we might be interested in not having the entire LCD screen turned on. That is, we don't want to light up the whole background, but rather we only wish to show the image. So we would have to generate a background that contains only the head, creating a background with blank pixels that includes only the head and not the entire background. Well, in that case, we go to the background and set the background fill to none. And we are going to generate a white background, but only in this case for the head. We generate a new mask, we call this mask background, we indicate that it should be solid, on it would be white. In a well, as we saw before, from the inside to the outside, it does not detect the edge well. So what we are going to do on the contrary, is remove the parts we do not want. So in this case, we invert the mask. Now the whole mask would be white, and we are going to exclude the parts we do not want, which is the background. For this, automatic subtract. Well, on the left side, it is not really necessary, because there they are well differentiated. It distinguishes the boundaries between the white and dark brown well. On the right side, the hair tones and the background are practically the same, so we increase the sensitivity to the maximum. As we must try to ensure that nothing gets inside, that we do not allow the mask to end up overflowing, no? Well, we pretty much have the background of the head ready now. The background on this white, what we have here is a white background applied only to the head and not to the entire screen we are seeing. Well, the rest of the masks don't appear here because the background is in the last position. So what we have to do is send it to the back. And now we would have the image without including all the white pixels on the screen.